Here's the solutions to the second perfect problem for Math 95. We're asked to solve this equation for x. So let's see, this equation we have rational expressions equal rational expressions. You may remember that the best way to deal with these is to make it so we don't have rational expressions anymore. That is, get rid of all of the denominators. Figure out what the least common denominator is and multiply both sides of the equation by that. So you might be able to just see what that is, but just in case you can't, let's get a little clever here. And instead of writing x squared minus 1, we recognize that as a difference of squares. So we can call it x minus 1 times x plus 1. And then it's a little bit easier to see that the least common denominator is x minus 1 times x plus 1. Right, x minus 1 here, x plus 1 here, and both of them over here. So what that tells us is that x cannot be 1 or negative 1 if we figure out what will make those be equal to 0. So good to write this over on the side just in case when we solve this whole thing out we get one of these solutions, because we want to make sure we don't claim one of these are the solution. So what are we doing here? Let's multiply both sides of the equation. I'm going to multiply all this stuff by our LCD. And what ends up happening if we distribute through is we'll get 3, let's go back to red, 3 times x minus 1 times x plus 1 divided by x minus 1, so that's this term when we distribute these guys through, plus 2x times x minus 1, x plus 1, over x plus 1, this term right here when we multiply this through, and that's equal to 6 times x minus 1 times x plus 1 divided by x minus 1 times x plus 1. When you get a little bit better at these, you might not distribute these all through, you might just cancel immediately, but I figured it was worth writing it all through so you can see what's going on since we're still relatively new at these. Let's see, in this term you got an x minus 1 on the top and an x minus 1 on the bottom. In this term you got an x plus 1 up top and x plus 1 on the bottom. And in this term you got both. So when all the dust settles, we have 3 times x plus 1 plus 2x times x minus 1 is equal to 6. And we know we did everything right because there's no fractions left, nothing left in the denominator. So now we have this equation, which is a little bit easier to solve. We're still not done yet, but having no fractions is nice. We can distribute the 3 through to get 3x plus 3. And distribute the 2x through to get 2x squared minus 2x. And then if we start to combine like terms and bring everything to one side of the equation, we got 2x squared as our only term with an x squared in it. 3x minus 2x leaves 1x. Then we have plus 3 over here, but if we subtract 6 from both sides, we'll end up with minus 3 equals 0. And the reason you want to set it equal to 0 is because if we factor the left-hand side, then we'll be able to figure out the solutions. Let's see, 2x squared has to be 2x times x. And then we want things to multiply to be negative 3. So negative 3 positive 1 or negative 1 positive 3. And when we put them in and kind of FOIL out, we need to end up with positive 1 in the middle. Let's see, how can we do that? Maybe we'll make positive 3 over here and negative 1 over here. Let's see, 2x times negative 1 gives us negative 2x. 3 times x gives us positive 3x, so positive 3 minus 2. Sure enough, that does work out. And the nice thing about this form, something times something equaling 0, that can only happen if the first thing equals 0 or the second thing equals 0. And these are two equations we can solve. X minus 1 equals 0. Let's add 1 to both sides and get x equals 1. And over here, 2x plus 3 equals 0. Subtract 3 from both sides, and then divide both sides by 2. And so we get two possible solutions down here, x equals negative 3/2 and x equals 1. But if you remember from earlier, x can't be positive 1 or negative 1. So this guy right here is not a solution, and our only solution is x equals negative 3/2. Maybe over here we could write not a solution so that our work makes sense. And that is the end of the second perfect problem.